Welcome friends, welcome you all in my channel Chemistry and Chemistry of Molecules. I am Tanmay. So today we will discuss a very important topic, that is preparation of alkene. So today's lecture will be little different. For example, here I shall first discuss about disconnection approach, means how to think that alkene could be synthesized, first point. And this will be completely explained in details. But the second point, the reactions in which the laboratory preparation of alkene is done or could be achieved, I shall give only you the information reactions, no significant explanation. Why? Because every videos I shall explain later, every reaction I shall explain in details, but here only just information. So this is the explanation. So let's start. Here the disconnection approach, what do I mean? Our target is to prepare a alkene, means a double bond. If we look at closely, this is actually made of this is one sigma bond, one sigma and one pi bond. So sigma bond, we know this head on overlap, means in this way head on overlap, and pi bond is this one. Okay, so this is in this way bonding overlap happens. So this is the main thing about bonding about alkene. So when we have to synthesize this, we can think this pattern in this way, that one strategy should be sigma bond previously there, sigma bond there, sigma bond present. What do I mean? Means there will be a sigma bond from the previous time also. This sigma bond is there. Now we have to prepare only a pi bond. How we can prepare? For example, we can think that it could be done in presence of, this is a negative charge, this is a positive charge, in this way. So how this thing could be done? So we can think that here should be one hydrogen and one should be leaving group. How? And we think that base, we will give base, that will abstract this, and in this way this. So this could be concerted or discrete. Based on that, it is named as E1, E2, even E1CB. So those things I will later explain in detail. Just keep this information in mind, as this today's video is mainly information based. So this is called, means if it is halogen, then dehydrogenation. If it is alcohol, then dehydration, in this way. So this is the strategy, plus and minus. Okay, and minus, if proton is abstracted, there will be minus generated like this, and halogen, it is more electronegative. That's why this is already plus center. This strategy is called strategy 1. Strategy 2 means preparation of two bonds at the same time, means this pi bond and sigma bond, we will form these two at same time. How? For example, we can think this in this way, that this is a double bond. So let's disconnect the double bond completely. Means disconnect using this. No bond is there. This side is plus and this side is minus. So two bond we have to prepare. Then we can consider the source of such thing is carbonyl. This and this is a carbanion type derivative. Okay. So carbanion. Okay. And in this way, reaction between carbanion and this first will produce what? An alcohol derivative. We can see like this. This is a carbon. Okay? And after that, this alcohol, this thing will leave to produce that final alkene. So two step in a same reaction. And finally, another strategy is preparation from a triple bond. So means, what do I say? This third strategy is preparation from triple bond. Triple bond means previously we have seen starting from single bond, directly double bond. So right now triple bond. How? What? Even if we take triple bond containing these like alkynes, triple bonds are mainly alkynes. So this could be prepared in two ways. One is, means actually this is triple bond to double bond, that is a hydrogenation, or more specifically if we say partial hydrogenation. So for this I have made a dedicated video. So one is linear catalyst, another is Birch reduction. So I suggest you please see those videos. You have a clear explanation. Okay. Then it is linear catalyst. Linear catalyst, what do I mean? Palladium, calcium carbonate or barium carbonate or barium sulfate, hydrogen as a reducing agent, quinoline and lead tetraacetate. So this is the reagent. What will produce? It will produce cis-alkene. This is a selective reaction. Okay, R1, R2. This is a cis-alkene. Okay. Similarly, if this reagent is react with sodium liquid ammonia, here the need of alcohol, you can use the alcohol as a hydrogen supply. Even in absence of alcohol also, this reduction could be possible. Then proton will be abstracted from ammonia, and here selectively trans there. The whole mechanism I have explained in the video. Please see that. So this is R2, and it is selectively trans alkene. Okay. So in this way we have seen this. So first I have explained that this strategy, third bond. Right now in second I shall explain about the strategy number 2. What is the strategy number 2? Actually I am going little reverse. Means generally 1, 2, 3, I am going to 3, 2, 1. Because there is a reason. This one is a little big. So the second strategy is this, and this is called actually Wittig reaction. WITTIG. Spelling may be wrong. So please check about name reaction, because those scientists' name is difficult, they are foreigners. So Wittig reaction. So this is, and what this reaction is actually? This reaction is reaction between a carbonyl plus a carbon ion, or more specifically we say this is a phosphorus halide. Like this, and they react. First these attacks, because carbonyl is electron deficient or it's the electrophile. So this carbon attacks here, and it produces a O minus, and this CH2PPH3 plus, and this minus attacks with this phosphorus center. It attacks to produce this bond, a 4-member ring intermediate, and these intermediate rearrange further to produce this, and phosphorus have a better affinity for oxygen. That's why phosphorus takes oxygen, and CH2 comes here, and this is also alkene. Okay, fine. Now we will discuss about the first part, which is the sigma bond already present. Okay, so let's discuss about the first part. So here you can see sigma bond is already present, and another most important thing, preparation of alkene is one of the best from alcohol, because it is very easy to get alcohol. For example, you all know ethanol, and somebody have already tasted this also. So this is produced a large scale in worldwide. So these alcohols like ethanol, even you can take propanol, or simply you can take isopropanol, we can take tertiary butanol. Such type of different alcohols are available, and dehydration produces alkene. And actually dehydration means in presence of acid. What acid they use? The acids are like sulfuric acid H2SO4, phosphoric acid H3PO4, or even some base catalyst, means alkaline type substance like alumina, but in this case higher temperatures are required, Al2O3. So such type of acids, these things are required to produce, and this reaction produces carbocation as an intermediate. Okay, carbocation. And I suggest you please see my stability of carbocation videos, then you will have a complete understanding about carbocations. Okay, then C plus. And how this reaction happens? Because these are strong acid, they releases proton, and the proton is protonated this alcohol to produce this, and this water molecule now leaves to produce carbocation. Initially alcohol is not a good leaving good, but after protonation using strong acid produces this carbocation. Okay, fine. Then these carbocations, for example, if we consider this This is carbocation. Now this carbocation undergo elimination to produce, means proton is abstracted by solvents and this produces alkene. But keep it in mind, such reaction required heat. Okay, and if we check the feasibility, that tertiary this reaction is more feasible if we consider the rate. This is number 1, this is 2, this is 3. Why? Because the RD step or rate determining step is the formation of carbocation. Okay, and we know rate determining step means this step actually affects the overall reaction. So here the rate determining step is the preparation of carbocation. That's why the preparation in case of this carbocation is stable, so energy of activation is less, so this formation is easier compared to this. So this is the preparation of this alkene via acid catalyzed dehydration. So right now I shall explain about base catalyzed, and that is actually we don't use alcohol directly for base catalyzed elimination reaction. We use the alkyl halides, but this alcohol could be used in base catalyzed hydrolysis. For that we need to RCH2OH. So we have this OH, but we know in alkaline medium OH was a good leaving group. That's why we need to convert this OH into a leaving group, that is tosylate. What tosylate looks like? Tosylate looks like this. For example, if it is considered OTS, then this is OTS. Okay, so this is the tosylate. So this, then it became a good leaving group, because if minus is here, that is stabilized. So this leaves and produced alkene, means RCH2. So alcohol could not directly be used in alkaline condition, but its derivative, this tosylate type derivative, could be used. First. Second is the dehydrohalogenation. What do I mean? Dehydrohalogenation. Previous reaction was dehydration, means water removal. Right now dehydrohalogenation means hydrohalogen means this HX, x equal to ClBrI, this thing. So HX, so we have HX elimination. Okay. What do I mean? Means this CH2X. Okay. So what will happen? The base will abstract this proton. This go this like this. It can happen 3 mechanisms. I'll explain later. So in this way, this RCH2 is produced. Now you can observe one thing, that another possibility and generally base used is alcoholic KOH. Okay, why generally alcoholic KOH, not NaOH? Because the solubility of potassium hydroxide is more in alcohol compared to sodium. Okay, that is the main reason you have seen many where alcoholic KOH. Okay, fine. So right now there is a chance also it can have a substitution reaction, means HO will attack here, and substitution means the product will be alcohol. It's true that there is substitution possible, and it is a competition reaction. What do I mean competition? Because elimination versus substitution, and this reaction is favored upon heating. What do I mean? Because we know the formula delta G equal to delta H minus T delta S. Okay, and in substitution another material is produced, HX. So here if we consider substitution, from 2 to 2 is produced, means this reactant and nucleophile produces another product and leaving group. But here another additional product is produced, means reactant plus base produces these 2 reagent. So entropically this thing is favored because of additional HX production. So this, and if we have to take the advantage of entropy, then if we increase the temperature, then delta G will be more negative. That's why generally it is observed that upon heating, this elimination reaction favors over substitution reaction. Okay, so this is the simplest dehydrohalogenation, and in this case there are 2 rules are well established. What? Set-Zepf rule is set CSA-YT-ZEF. I'm sorry, I may have done mistake. Okay, let me check the thing. Okay, ZEF, or you can say ZAIT-ACV. Actual the surname of the scientist is ZEF. It's a Russian scientist, and this could also ZEF. So this spelling may be mistake. ZEF rule. What does this rule means? If there is a chance of formation, for example, if we check R, CH2, CHI and CH3, then there is a, for example, let's take R equal to methyl. So one thing can happen, one possibility, that CH3, CH means hydrogen can be abstracted, this hydrogen can be abstracted from here, or hydrogen can be abstracted from here also. So 2 beta hydrogen. Okay. So what possible in presence of base? If this abstraction happens, it will produce a more substituted, means double bond will be in between. So the product will look like this. Okay, I am not going to geometry, means cis or trans. Later I shall explain details. So this, and if this is abstracted, then the product will be CH3, CH double bond CH2 double bond. So it's a less substituted. What do I mean? This is less substituted, means double bond is attached to carbon, which is less substituted. Now this is more, according to ZEF rule, this is produced in case of base like alcoholic KOH. Why? Because more stable. How? Because alkene is stabilized by hyperconjugation. That means here 3 plus 3, 6 hyperconjugation are possible. But if we consider here, only 2 hyperconjugation is possible. So this is the ZEF rule. But the question, is it difficult to get? No, it is also possible, and that is possible by following another rule that is called Hoffman rule. Hoffman rule means what does this rule indicate? Means if this is, then first, not this substrate, such substrate we need to convert first into amine. Okay, we need amine first. So this is amine, and we know that Estueller-Clark methylation alkylates amine. For example, this amine, this NH2 could be converted into dimethyl using Estueller-Clark methylation. I have made a video about it. Please go through, you have a detailed knowledge how to make such substrates. Now this substrate it produce, it need to be alkylated using methyl iodide to produce a tertiary iodine. And if it is methyl, this is plus, and iodide is there. Okay, this is after reaction with methyl iodide, and this is further reacted in presence of silver oxide, Ag2O. What happens? We know that silver loves halide, so silver eliminates halide from this as a silver iodide precipitates out, and in this way what remains here, that is hydroxide. Okay, and previously I told that elimination reaction which produces alkene is favored when heating is happened, and actually when heating is happened, this substance it produces mainly as that less substituted alkene. So according to ZEF, this is the, according to the ZEF rule, this is the major product, and according to Hoffman rule, this is the major product. Okay, so I guess you got it, that dehydrohalogenation of this alkyl, means alkyl halide may follow this, and if it is converted into amine using ZEF rule, this could be converted into a least substituted one. Okay, so this much we have explained. So right now what we are going to explain, another is there, that type of reaction is geminal or vicinal dihalide using acetone. What do I mean? Geminal or vicinal means if it is 1, 2 Br, this is called vicinal. How you can say that two neighboring countries you need visa to go? So in this way you can remember what is vicinal, or close word is visa. Okay, so this is vicinal, and what is geminal? Geminal is, you can consider this like this is Br or this is Br. In this way, same carbon. Okay, so what happens if this is treated with zinc dust? This produces alkene, this one, and here also vicinal also produces this. How this could be done? In presence of, so how this? Actually you can use sodium iodide in acetone. Okay, sodium iodide or potassium iodide, and then this reaction will ultimately end up with alkene. Okay, another, even using strong base, very strong base like sodamide, that can be double elimination, can produce, sorry, I made mistake, not sodium. So this is single base, so sodium iodide, this thing can result in double bond formation, and this is also by reduction it produces, what happens, this thing produces a carbene type derivative. Okay, and that carbene type derivative means this two, and that combine to each other and produces the final alkene. And here even if we add zinc dust, what produces? They initially produces an alkyl zinc Br, this derivative. In this way, previously carbon was in plus, right now it is in minus because it adds to zinc. Then it reacts and this leaves. Okay, in this way reaction goes on. So this is, you can say, the end of these laboratory processes. For example, there are other few methods like if you do Diels-Alder reaction, this plus this with an electron withdrawing group, what it produces? It produces a double bond. It's true. So logically it should be considered as a double bond formation reaction, but we don't consider because reaction in double bonds are there. So such type of reaction I am not going to explain. Some basic reaction I have explained. Another thing I didn't explain about industrial method for the preparation of alkene, which is mainly done using petroleum cracking. So in another video I shall explain that. And if any reaction I have missed here which is important for you, please mention in the comment box. I shall make the part 2 for this alkene preparation reaction. So this is the end of the video. If you like my teaching, please give us a like and share this video among your friends such that many people could be benefited and to get the notification of every single video I upload. So in this is the preparation of alkene I have made. So if you people want preparation of alkene, which is not that much important I believe, please tell me in the comment box in later, then I shall upload a video preparation of alkene. So next I shall explain the properties of alkene. Okay, so bye, let's see you in my next video.